Hello everyone, so in this video, let's talk about a medium level problem from lead code. The problem is find the power of k size subarray part 1 and part 2. Okay, both of these are literally the same, only the constraints are different. It is of length 500 and it is of length 10 to power. Okay, so what I've done here is that I will tell you the brute force, but I will directly jump down to the, you can say, optimized approach. It's pretty much simple. We'll go through the overall examples as well. So don't worry. I will directly jump down to sub array part 2. So in one also, I'll tell you the very brute force. So let's go over the problem statement. You are given an array of integers nums of length n and a positive integer k. So you are given an array, as you can see, of length n and a positive integer k. The power of an array is defined as its maximum element if all of its elements are consecutive and sorted in the ascending order, or minus one other way. So the power of an array is defined as, if I go again, the maximum element of all the elements in that array, and the elements are consecutive and sorted in an ascending order. Okay, so if the array elements are sorted in an ascending order and they are consecutive, the maximum element is the power. You need to find out the power of all the sub arrays of size k. Let's take some example to make it more clear. As you can see that we have an nums, we have to find out the power of all the sub arrays of size k, that is equal to 3 here. So the size sub array or 3 size sub arrays of this particular array is, as you can see, 1, 2, 3. The first three. Then 2, 3, 4. Then as you can see, 3, 3, 4, 3, and so what. So as you can see, the first three elements, the next three elements, the next three elements, all are consecutive sub arrays of size k, and you have to find out the power of all of them. The power is that all the elements should be sorted, they should be increasing order, and they all should be consecutive. So whatever is the maximum element, the maximum will be the last element. That is the power. So let's take this again example. What you can see here is that the first subarray of size k, that is 3, you can just imagine it down here. Okay, this, the maximum element is this, all of them are consecutive, the answer is 3 here. As you can see, the next subarray of size 3 is equal to 2, 3, 4, so the maximum is again 4, that is again here. Now the next is 3, 4, 3. Now 3, 4, 3 is bad because they are not consecutive, so answer is -1, and similarly 3, 4. So 4, 3, 2, again non-consecutive, and 3, 2, 5, not consecutive. Sorry. Okay, so that's the thing that you have to print out. Now, in the brute force way, you can again do this in a very simple way. Take every subarray of size k equal to 3. Okay, take every subarray of size equal to 3. Check that all the elements should be consecutive, and you can say that the last element is the one that is the answer. Okay, so you will take for every starting point the k consecutive elements, so the k can be at most the all the elements. So as you can see, like all the elements are there, like so the maximum you can get is O of n square. Okay, that is, as you can see, for every, let's say, sub area of size k, you will check that starting from here. So you can say O n into k, whatever you can think of as it is as well. So that's the overall time complexity, and it like can exceed our time complexity that is required for us. So what we can optimize here? One thing that I can surely say that the last element of the sub array, whatever we are looking at, is the one that is I'm looking for. That is the maximum, that is the power. The only thing that I'm thinking of is that if I have some array, let's say 1, 2, 3, 4, 4, and then next element is 4, and then 3, then 2 and 5. What you can see here is that if I find out the power of the first sub array, let's say of size k, can I somehow utilize information to find out the next sub array and next? So I can assume it to be some sort of a sliding thing that I'm just thinking of. If I can think of it as a sliding thing, how can I use it? What I can think again of here is that I can first push all the k elements and just find out that this is the maximum. While pushing, I have to ensure that I can push it inside some, let's say, q. I can push it inside some vector. I can push it inside some DQ, whatever you can think of. I just have to push it. Let's say it's some sort of a array or vector, whatever you can say, or some queue. I can just keep on pushing. Let's say then 3 is there. Let's say the first element is 1, the next element is 2, the next element is 3. I can push in some sort of a data structure, ensuring that the current element that I'm pushing should be one larger than the previous element that is already present inside the queue. Okay, because they should be consecutive. So while pushing, I have to ensure that the previous element already present inside the queue should be one smaller. So all of them should be consecutive. Whenever the length becomes, let's say, whenever I had to find out the power, the last element is the power, and I can directly just pop out from this particular, or let's check in O of 1 what's the last element, and you can directly just print it out. The overall thing now is, let's say I encountered an element that is 5. Let's say I now encounter an element 5. It is not consecutive. So which means that I have to now start afresh. Let's say it can only happen that this is the 5. Let's say the let's say this it is 3 4. Now it turns out to be 3. So it means that all the previous elements are now wasted. I can only have a consecutive thing. Let's say if I have 3, then again 4, and then 5. So which means that if I have 3, all the previous elements are not counted. So I have to somehow clear the complete data structure that I have. Let's say I have Q or whatever data structure I have. Whenever I find out a mismatch that it becomes 3 to 4, then 4 to 3, it becomes a mismatch. So whatever data structure I'm used to store out all these elements, just clear this out and start a new data structure with 3 as the first element. Then again, let's say 4 is the next element, and so forth. And whenever, let's say I have in this particular array at least k elements, because I have k elements to find out what is the maximum element. If the element is less than k, then the answer is -1, or the answer is. That's a complete logic. I'll move down to the code part, but that's the overall idea that we have to use to solve this particular all about. Let's move on to the code part now. I've used a DQ here. You could have used a string. You could have used a vector, whatever you want. Not a string because the number, so I can use a vector, whatever you want. So I've used a DQ here. Okay, and this is the vector to show the answers. I have pushed the first element in the DQ because the first element is always there, and the constraints are there that n equal to greater than equal to 1. So I push the first element. Then I will start from here, and I will check that, as you can see, if the previous element like if the DQ is already present, if the size is greater than 0, because the size can also become less than 0, because I could have completely deleted all the elements of the DQ. Okay, so I've started from the first character or the first number, and I check that if it has some particular numbers, like if the DQ is not empty, and the front or the first element, the already pushed, the current pushed element, if that is one less, because I have to be consecutive, so the current number should be one greater than the previous number that is last pushed inside the DQ. So if that is that, then that is there, then it is fine. I can keep on pushing in the DQ. If it is not fine, which means that the last set is not 1, so which means that the consecutiveness of this particular subarray that I'm building is breaking. So now I have to just clear the DQ again and then push the current number. This ensures that I have pushed the numbers in a consecutive manner. Okay, then I have to now start pushing. So I have pushed for the first k minus 1 character, like the numbers. Now starting from the k, because I have to take from the k. Okay, the first from k to all the subarrays. Okay, so the first k minus 2 are not the subarrays because these are smaller subarrays. After k, I can start building the subarrays of size k. Okay, so I have started from so k minus 1, which means that I have pushed to k minus 1. Now I have started from this string to find out the the subarrays of size k to all the length till the very end. I'll just have to do the same logic here again, that if it is not consecutive, clear the DQ. If it is consecutive, push the complete, like let's say the character inside it, or the actual number inside it. Now what's the logic here is that now at any current state, I am ensuring that the sequence I am pushing inside the DQ is consecutive in nature, and if it is consecutive, it is already ascending in nature. So in that manner, I can just know that if the DQ is sorted, and it should be having at least k, because I am clearing it out as well. If I'm clearing, which means that if it is cleared, then it doesn't follow, the last k characters doesn't follow, or the last k numbers doesn't follow the consecutive pattern. So if it doesn't follow, then I just have to push back -1. Okay. And if the last k characters are already there inside the DQ, which follows the consecutiveness pattern, then I can take the very maximum or the last number in the DQ and push it inside the answer. That is the power of the sub array that I'm building. Okay. Look inside the code. As you can see here, that if the length of the DQ, let's say I'm taking an example as well here. Let's say I have 1 2 3 4. Okay, 1 2 3 4. I'm keep on pushing that inside, let's say, a DQ, and I know that there is the size is at least equal to k, which means that if I've taken this as a sub array, the power will be 3. If I've taken this as a sub array, the answer will be 4. But let's say now it breaks at this point. Okay, so now it breaks at this point. I will take now 3 only as the element inside the DQ. But now at this point, I can also make this as a subarray of the last 3 characters. But because this doesn't follow, how I could have known this? Because when I'm pushing 3 inside the DQ, it doesn't follow the particular pattern, the consecutive pattern. So I've cleared all the particular numbers from the DQ and I've just pushed 3. If I've just pushed 3, which means that now my particular pattern is starting from 3, but at this point there are already 3, let's say, numbers, and we only have a pattern of 3, which means that there is some discrepancy, which means that this discrepancy is there in the order, which means that if there's a discrepancy, I cannot find out the power, and the power is -1, so I push -1. If there is a DQ that is completely built of at least k size, which means that I keep on pushing, and the maximum value, the maximum of this particular DQ, so the answer will be the front, that is the maximum element. Okay, that's the power. That's a complete logic, and that will completely solve this particular out, because I have doing this in like O of n. That's a complete logic on the particular code for this particular problem out. If you still have any doubts, you can mention on in the comment box of this particular video. Okay, and thank you for watching the video till the end. I will see you in the next one. Keep coding and